Brian's Mobile One.
2019, this is a Kia Optima. The problem is you turn the key on and it doesn't matter where you switch this, it doesn't work. It only works when it's hot outside or in the car. If it gets cold at all, either if you set the AC cold or if you have it cold outside, it won't work. So in order to diagnose this, first thing you do, in the words of the famous Rodney Norman, you fiddle with the fuses. So we're looking at a 10 amp at the top above the fuse switch. So I checked that, it's this guy right here, and that checked out as being good. So the next thing you want to do is look at the fuse box under the hood. And you have two fuses for the blower, or two apparatus circuit protection. You got the blower relay, that's this one right here. And then you also have a blower fuse, 40 amp right here. You see these all in a row, and they all say battery positive, battery positive. So that is these guys right here. So looking at these power bars that go to this, I assume it's this one. They both read either way at battery voltage 11.9 is what I'm picking up here. I've been testing on it for a while. I need to get a charger on this. But yeah, this is all good. And this should be battery voltage. It actually came up a little bit. It's 5 now. That's not enough to run a blower motor. You gotta send 12. So this is weird. I pull this leg off and it should still be connected somewhere around. Anyway, instead of going to 0, look what it does. It goes to 1.4 volts instead of 4 or whatever it was before. That's weird. It should be dead. So let's just keep taking stuff apart. We have so many BCM codes. I'm looking for corrosion because there should be some kind of resistance for it to drop in voltage the way it does. But I don't see anything. So I've got that pulled out. I think something was feeding back through that. It should be 0 now. Nope, still 1.312. So this is Kia's wire diagram. This is the wire that's putting out low volts. And so it says it's junction block, but it doesn't say that it's that great big long fuse. Blower resistor is under the passenger kick well. And then that's the switch on the dash. And it just distributes ground as indicated by this guy right here. Wild. I don't know what the heck's underneath. It looks so simple right here. If I take the fuse blocks apart and put voltage to it, it would work. So this is fun. Here's some quick access to some wires. I thought stuff was burned, but it's just glued to the foam. So that green wire that we're looking for is down here. You can see it coming up through the bottom. So I want to trace that back and see where it gets up into the bottom of this and see if I can hook stuff back up and probe and figure out where it dropped. But what a fun idea to have access to something. I mean, it's just like, what is this, 1950s again? This is great. So in order to get these out, you have to pull out this 10 millimeter nut. And then with that out, you can pull these back with pliers or a screwdriver, but you really got to pull hard on them. They don't come out easy. And then you got to rock them because there's a bunch of blades stabbing in there. Blade connectors, so you got to work it up on both of those to check those. So what I do first when I'm diagnosing something like this is I like to pull the relay and just pretend that because of Omron relays and Hondas, I pull the relay first. This is not a Honda, it's a Kia. And in this case, the fuse was good, but you got two prongs here and here. This one's positive, this one's negative, and that connects the circuit. And then you've got a back one that's supposed to supply battery voltage. And then you have one in front of that, and that's supposed to be a direct line to send power to the blower motor. So what I do is take battery voltage via a power probe or jumper cables like this and see if I can get it to go. I could get it to go with my knockoff power probe because my other ones are serving elsewhere. So I do this one, but this one only goes up to a certain amount of amps, and it didn't go up to the 40 amps that this needed. Maybe it's 10 or 15 or something. It's got some circuit protection in it. But when I did that, I could hear the blower motor kick on to whatever speed it was turned to. So if it was at the first or second setting, then it would work. If it was anything other than that, it would not work. So I thought that was interesting, and I didn't notice, but the voltage was low here, and that was the key to diagnosing this. If you want to send power directly to the blower motor, you go underneath of here, and you've got these tabs that you pull back on. So if you look in here, it's got a tab that you can see from underneath. So you got to pull these tabs, and they're spring loaded. You got to actually push them the other way to get this to come down, and it will show the blower motor underneath. So that's the blower motor, and the wiring is kind of backwards. The green wire is the power wire, like in house wiring. Green is your ground for your GFI or whatever. The pink wire is the wire for ground that goes to the switch. So there's your blower motor, you can see it there. When you look up here, there's a computer for the air conditioning system, and this is the manual, it's not the automatic one. And then you look over here, and I believe this is the blower motor resistor that you have up there. So you can see your green wire and your pink wire and all that. So that's where those things are located. Pretty accessible compared to some cars. So whenever you have it set to 4, you've got a direct shot with no resistance, full power, or full ground in this case, because this has a ground going to it. And then each of these positions, 1, 2, 3, are through the resistor, and then 4, like I say, it's a direct line. 0 is open circuit. So that's what you need to know. Let's come back out here. The wire that goes from this fuse about right here for the blower resistor that we see here, the 40 amp, goes underneath this and then up to that post here, and that's supposed to be battery voltage all the time. If you were to run a wire from your positive to that and bypass all of this, it would work. But what happened is the connector wasn't big enough for the pin coming off the 40 amp. When you look in this, you can kind of see through these things. I'm going to backlight this, but you can check these this way. And if you look at the one for the blower motor right here, it's kind of dirty looking. So they all look kind of gold, and then you get to this guy and it looks kind of burnt up and dingy. That's because the plastic all around it melted and it created resistance. So if you have a drop in voltage, that means that you have some resistance. And so the resistance was that connection there of the green wire, the big fat green wire that goes up underneath of there. Once I got these pulled out and I cleaned up the contacts on both, and then I bent it a little bit so it would bite into it more, then it's been fine ever since, whether it's hot or cold. And I'll show you where we're at now. So it used to be whenever they would try to run this in the cold or with the AC on, it would just cut out. So you can see there's nothing going on now. You can hear the blower motor come on. If I stick my microphone down there, you will. Set it there. And then we'll turn to number 2, probe. And then 3, it would just flat out go out. It wouldn't do anything. Because it's computer controlled, it was a little bit tricky. And because the connection wasn't visible without taking things apart, it was a little bit tricky, but I got it figured out.
Bonus footage at the end.